Hey everyone, welcome to today's tutorial. If you are new to deep learning or just getting started with Python or Keras, you are in the right place. We are going to build your very first neural network using Keras, a beginner-friendly deep learning API that runs on top of TensorFlow. By the end of this video, you will have a working understanding of how to build and train neural networks to recognize handwritten digits using the MNIST dataset. Keras is an open source deep learning API written in Python. It allows for easy and fast prototyping and supports both convolutional and recurrent networks. Keras runs on top of TensorFlow and it simplifies building neural networks. You define the model architecture, compile it, train it, and evaluate it, all in just a few lines of code. So let's begin by installing TensorFlow. So you have to type pip install TensorFlow to install it. Okay, so this will be the first step if you have not installed TensorFlow. Then we will move on with libraries. So we will import required libraries first. So I'm doing everything in Jupyter. Okay, so first line of code is import TensorFlow as TF. So we are going to import by telling Python to bring in an external module. TensorFlow is the module name, and as TF means we will refer to it as TF throughout the script. It's a shortcut. Okay. Next library is from tensorflow.keras.datasets import MNIST. So we are importing the MNIST dataset from Keras from TensorFlow. Okay. So we are going to install this MNIST. Okay, so which means we are using dataset module inside Keras, which is a part of TensorFlow. MNIST is a built-in dataset with 70,000 images of handwritten digits. Okay, then moving on with the next one, that is sequential. So this line imports the sequential model class. A sequential model means the layers are stacked one after the other in sequence. There will be no branching present. Then we are importing dense and flatten. We import two layers here. Dense is a fully connected layer. Every neuron connects to every neuron in the next layer. Flatten reshapes the input from 2D, like for example 28 into 28 image, into 1D. So it will be getting converted into 784 elements, somewhat like that. Okay. Then we will import to categorical. So we import to categorical, which converts labels like 5 or 7 into one hot encoded vectors like 0, 0, 0, 1, 0, 0, like that. Okay. Now we are going to load this MNIST dataset. Fine. So for that we are having this particular set of code. So the first line says that we are having x train, y train in one round parenthesis. Then we have added another set where we have added x test comma y test, which equals mnist.load data. So we use mnist.load data to load our data. X train and y train are training images and their labels, whereas x test and y test are test images and their labels. The parenthesis around them lets us unpack both training and testing data in one line. Moving on with this particular set of code. So here, before that I have just forgotten to explain this. So what does this mean? So we have print statement for training samples xtrain dot shape, whereas print testing samples xtest dot shape. So in this we print the shape or size of our training and testing sets using formatted strings. So dot shape shows the dimensions of the array. For example, it might say 60,000, 28, 28, which means we have 60,000 images of size 28 cross 28. Okay, we are going to pre-process the data now, which is nothing but normalizing it. So we have xtrain equals to xtrain by 255.0, xtest equals to xtest by 255.0. Each pixel in an image has a value between 0 and 255. So dividing by 255.0 normalizes the pixel values to the range 0 to 1, which helps the model train faster and more accurately. Fine, then we have this next set of code where we have written um, model equals to sequential. So we create a new neural network model using sequential, which stacks layers in a sequence. Everything inside the square brackets will be added layer by layer. Okay, so inside that we are adding many options. First one is flatten, which converts each 28 cross 28 images into a 784 element vector. We just saw while importing it, right? So this will convert it in that way. Then we have dense 128, which is something new for you. So dense 128 comma activation equals to ReLU. Now what is this? So we add a fully connected layer with 128 neurons. Okay, so dense 128 means 128 nodes in this layer, whereas activation equals to ReLU uses the rectified linear unit function, which returns 0 if the input is negative and the input itself if it's positive. Then we have a similar line where we have added 64 dense layer. Okay, and then this one is again something new where we are adding dense 10 comma activation equals to softmax. So finally we add an output layer where dense 10 means 10 neurons, one for each digit from 0 to 9. Activation equals to softmax converts the outputs into probabilities. So values between 0 and 1 that sums to 100%. Fine. So we have this particular option here. So model dot compile. So it's time for compilation now. So next we compile the model. This prepares it for training. Okay, so optimizer equals to Adam is an algorithm that adjusts learning rates during training, whereas loss equals to categorical cross entropy measures how far off our predictions are ideal for classification. And the last one is metrics equals to accuracy, tells the model to track accuracy during the training and testing. Now we have this options of called as history, which is nothing but training the model. So here we train the model using fit function. Xtrain and ytrain are the inputs and outputs. Epoch equals to 5 means the model will look at the whole dataset 5 times, whereas batch size equals to 32 means its weights are updated every 32 samples. And the last one, validation split equals to 0.2 means 20% of the data is used to validate the model after each epoch. Okay, now it's time for the evaluation. So we have this model. Okay, so we will use the function evaluate. Okay, you can see here. So evaluate, it helps to check the model on the test data it hasn't seen before. So it returns test loss and test accuracy. We print the accuracy percentage using formatted string. So we have printed the same here. We just got the output as 97.39% in our case. Okay, and the last but not the least is plotting the training history. So we have done so many things. Using all these things we are going to plot it. Okay, so we are going to import MATLAB for that, so which is nothing but matplot library.py plot. So we import this to plot our graph, which helps, this library helps us plotting. Then we have this plt.plot history and all of those things, which is nothing but we are going to plot the training and validation accuracy over epoch using the history object returned from fit, which we just got from here, from the fit one. Okay, from fit. Okay, and the y label, x label, all these things, what it is going to do is we will label the x-axis and y-axis, and then we will give the chart a title, show a legend, and finally display the graph using the plt.show. Fine. And finally we can save it. It's important, right? It's important to save our work. So we can save our train model using model.save. So MNIST model dot Keras, some people they use H5, it's up to the latest version that we are using. So we are going to give the file name, we will save the entire model architecture. Okay, so if you like, I can we can even turn it into PDF. Okay, if you want me teach you how to turn it into this script into PDF for printing or teleprompter, just comment it. We will have another video where we can look into it. Okay, so yeah, that's it. You have just built your first neural network using Keras. You have learned how to load data, pre-process it, build a model, train it, evaluate it, and even visualize the results. If this helped you, don't forget to like this video, subscribe for more deep learning content, and yes, drop your questions in the comments. Thank you so much for watching. Bye, take care.